Hello, friends, welcome back. In IR Spectroscopy Chapter 5, we continue exploring spectral analysis, focusing on the effects of conjugation and ring size on carbonyls, and the stretching of alkenes and aromatics. Infrared absorption regions are crucial for identifying functional groups. Here, we see the typical absorption regions for various bonds, including the CCl bond. The CX stretching region is significant for halides. CCl bonds are found between 785 to 540 cm inverse, while C-bridge and Ci are outside the useful range. CF bonds are rare but easily identifiable. Carbon tetrachloride is often used as a solvent in IR spectra, showing distinct CCl absorptions. Chlorobenzene's IR spectrum highlights the benzene ring combination bands and the CCl absorption. Next, we delve into the =CH out-of-plane bending, a key feature in infrared spectroscopy. Out-of-plane bending, also known as OOPS, occurs in alkenes and benzenes, with hydrogen atoms bending above and below the plane. For alkenes, the =CH out-of-plane bending varies with substitution patterns, as shown in this chart. In benzenes, the =CH out-of-plane bending also varies with substitution, with distinct combination bands. Modern Fort IR instruments automatically subtract the background spectrum, simplifying analysis. The background spectrum typically includes carbon dioxide and water, which are subtracted during analysis. Making decisions in IR spectroscopy involves using a flow chart to identify functional groups based on their absorption peaks. If a C double bond O peak is present, we can narrow down the functional group to anhydrides, acids, amides, esters, aldehydes, or ketones. If no C double bond O peak is present, we look for other functional groups such as alcohols, amines, ethers, nitriles, and more. This comprehensive flow chart helps in identifying functional groups by checking for various peaks in the IR spectrum. Guidelines for using an infrared spectrum include calculating the index of hydrogen deficiency and checking for key functional groups. Continue refining your analysis by checking below 1550 cm inverse for CO and nitro groups, and reviewing the spectrum for additional peaks. In summary, you should now have a secure grasp of reading infrared spectra and identifying functional groups. The minimum you need to know includes base values for common functional groups and the effects of hydrogen bonding, conjugation, and ring size. This brings us to the end of Chapter 5 of IR Spectroscopy. In Chapter 6, we'll dive into some IR questions. Take care, goodbye.